As a fault finder, I'm always intrigued with the past because the past can tell us a lot about where we're going in the future. Now, if I'd have been born quite a long time ago, over 100 years ago, I might have used something a bit like this, which is a 1920s antique, beautiful, basically pocket multimeter. However, I wasn't born so long ago, although I was born quite a long time ago. And today, what I use, like most of you guys and gals watching, is a DMM, digital multimeter. Now, this one is a cheap one, less than €30. It's a Maztec Cat 3 600 volt. And what I'm going to do today is I'm not going to go through how it works because there's a lot of videos basically online showing how to do the various functions on here. What I'm going to do is I'm going to actually show the two microchips that nestle inside this little unit, and we're going to try and sort of shed some light on how they work basically. And what we're going to do, we're going to strip it down on a bench and we're going to have a closer look inside it. Modern meters use microprocessors with lookup tables, very fancy, especially the true RMS fluke type ones. However, this one is basic and it uses just solid state circuitry to give you the final value displayed on that lovely LCD screen there. So let's go and strip it down and shed some light on this thing. Right, let's get the show on the road, shall we? So what we do, we just open it up and split it into two nice handy pieces. And we look at what's inside it. At the core of this meter, there's no processor, as I said. There's two chips, LM358 and the 74HC14D. So we'll look at the LM358 first. And what that is, it's a dual operational amplifier or an op amp. And that's the workhorse. What that does, it amplifies all the tiny signals that we're measuring, whether we're measuring voltage, current or resistance. And what that does, it makes the signals large enough to be basically processed further along down the line. I will actually include a slide at the end of this and it'll explain a bit further. But for now, let's move on to the other side of the multimeter. We've got another chip and that's the 74HC14D. That's an analog digital converter. Now this one is a bit special. It's a hex inverting Schmitt trigger. You can find more about that online. I'm not going to cover that here in this short video. And what this does, obviously, it converts the analog signals we're measuring into digital ones so that the meter can use it and display the right figure on the LCD screen. And this one is known for its role in cleaning up noisy signals, and it ensures that what might have started as not quite a clean signal, it turns it into a very clean, stable one, ready for the meter, and it's the meter's hardwired circuit to give you a more accurate measurement, if you like. And this one at the front is, obviously, don't really need to tell you, it's a rotary switch. It's a very simple system. It's quite crude actually in my eyes. It uses wipers and obviously they connect to various parts of that printed brass track on the circuit board, and obviously that then changes the meter to the various modes that we use, which you see on the front, which we won't cover here because everyone knows, I think pretty much everyone knows what the modes are in the meter, and if you don't, there's lots of videos online to see that. There's a couple of fuses in there, 10 amp and 40 milliamp, both rated for 600 volts DC, 600 volts AC. Nothing really fancy about that, although I don't really fancy using this to do any high voltage measurement. I think I'll stick to my fluke meter in that sense. So in this meter you have obviously an LCD display, and all it does is essentially does what I'm doing now, displays the result of the measurement that the meter processes. So how does it work? Well, the signal conversion starts with the conversion of the physical quantity, voltage, current or resistance, into an electrical signal, and that's achieved through various means such as a resistive division for voltage, shunt resistors for current, and a known current source for resistance measurement. And obviously the main job of this meter is to convert analog signals to digital signals. And that really is literally about it. It's a very brief video, so what I'll do, I'll leave you with a very nice slide, and these slides will just explain